Today we're going to continue with tar modeling the C++ type system. And I'm going to expand this model with what goes above kind, type and var. And spoiler alert, I'm going to add template. My name is Kjell-Olov. Welcome to tar modeling of the C++ type system, and we're going to continue where we left off in the previous episode, where we took this C++ code and entered it into the tar model like this. And the main takeaway here is that we're going to view the int, struct and union as operators. So int takes a variable name, in this case x, a value, and creates the x variable. So int is an operator. In the same way, struct is an operator that takes a name of a type and arguments to create that type. So struct is an operator, it creates, in this case, the type A, and it's an empty struct. And union, the same way, creates this U, empty union. So what about template? Okay, first I'm going to write a simple template here. So this template doesn't do anything, but let's examine. If you view template as an operator, this template then takes the first argument is a list of arguments. In this case, we provide a type name t. So we name the argument t, and t is supposed to be type name we feed to this template. And then comes this strange thing. So struct, already we said, is an operator that takes that is a kind operator. It takes a name and arguments to create that. So question is, what is f? Let's first continue the line of thought that template is something that creates kinds. Then it follows that f should be a kind. So template creates something named f, and f is a kind. If we look at C++ code, if we're going to use this template, then we can, for example, use it like this. Okay? Sorry, I made an error here. This thing, the f calling with an int, is of course a type, not a kind. And s here is a variable, not a type. And the arguments, of course, is the value to instantiate that variable. Sorry about that. I'm going to cover it up in this video and continue with what is actually correct. I'm going to motivate this by trying another way of explaining this, and that's taking this and look at it using some familiar C++ semantics, or syntax rather, and invent a new semantics for it. So I'm going to propose that this template here is as if we could write this in C++. Okay? So f is as if it was a function that returns a struct, takes an argument that is a type name, and returns this struct. So in this body here we define how this struct we're going to return looks like. And from C++ 11 we can also use the lambda syntax, and then we're going to write something like this. We're going to capture nothing. We're going to take one argument that is a type name. Okay? So, of course, this is as if. We can't write this in C++, but to convey the meaning of f, I think this is a good way of explaining it. So, f is actually a function. Yeah, I'm really struggling with language here, but if I use functional language, we take the f and run it. Okay? So, if we just swallow this line of thinking, we can ask, okay, if this is true, what do we call this thing above kind, type and var? What is this layer? Well, the best I can guess, and I think this is close to truth, in type theory sometimes these are called sorts. So template is a sort. And the pattern here is clear, although a little mind-boggling to grasp, is that template is an operator, something here, that is able to create kinds. In this case, we used it to create this. And f in turn is a kind, that is a function, that is able to create, in this example, a type. So we have that one. And then, of course, we can continue and use this type to create some variable down here. So the pattern repeats itself. It's nice. We've shown that template is a sort that can create kinds. We can then use that kind to create types, and then the story continues. So I'm going to stop there for this time, and hope to see you in the next episode, where we're going to elaborate more on this tar model of C++ type system and see what we can learn using this kind of reasoning. So I'm Kjell-Olov, and thank you for watching, and see you next time.
If you like my videos, feel free to do nothing.
Just grab a cup of coffee
and enjoy.